Hello guys, in this video I'm going to discuss past ME board exam question in machine design materials and shop practice last February 24, 2020. So here is the question. Neglecting spook effect, calculate the energy stored in the rim of a flywheel made of cast iron 24 inches in diameter, having a rim 5 inches wide by 4 inches deep when running at 1000 RPM. The internal radius of the rim is 8 inches. So note, density of material is 450 pounds per cubic feet. So the choices, letter A, 40,122.28 feet-pound. Letter B, 38,614.21 feet-pound. Letter C, 58,234.36 feet-pound. And letter D, 50,165.32 feet-pound. So let's proceed. Okay, so first we need to draw a diagram of the flywheel, so indicating the details, and then we identify the given. So given are the rim diameter, which is 24 inches. So here the outside diameter, and the rim width, so it is 5 inches, so denoted by letter B. The rim depth, which is 4 inches, denoted by letter T. Rim internal radius, which is 8 inches, so it is denoted by a small letter R. Angular speed, so N, which is equal to 1000 RPM, and the density of the cast iron, which is equal to 450 pounds per cubic feet. So our task is to find the stored energy. So in flywheel, the stored energy in a flywheel is based on its angular speed. Okay. So it is a kinetic energy. So when solving kinetic energy, so for a linear motion, it is 1/2 times the mass and the squared of the velocity. But in a rotational motion like flywheel, it is 1/2 times the inertia and the square of the angular velocity. Okay, so, and there is a note here, which is it says neglect the spoke effect. So let's proceed. For the kinetic energy of a rotational motion, like what I said before, it is equal to 1/2 times the moment of inertia and the squared of the angular velocity. So the moment of inertia, it is the mass moment. We have two moment of inertia, the area moment of inertia and the mass moment of inertia. Here we are going to use the mass moment of inertia since we are going to find the kinetic energy. So we need the moment of inertia is, in English system, it is equal to feet pound. The unit is feet pound second square. So while the angular velocity, it is equal to radians per second. So the resulting unit should be feet pound. Okay. So in our formula, so I is the moment of inertia for hollow cylinder. So we have a reference here for computing the moment of inertia, mass moment of inertia for hollow cylinder. It is our source is from the Engineering Mechanics by Ferdinand Singer, second edition, page 226. So if you want to know how to derive this equation for calculating the moment of inertia for hollow cylinder, so just comment below and I will prepare another video for the derivation of this formula. So m, which is our mass, so since the density is given, so we need to calculate the volume. Okay, so the volume times the density, so we can get from that formula, we can get the mass. Okay, so to calculate the volume, we need to get the surface area, which is the mean diameter of the hollow cylinder or our rim, since we are talking here about the flywheel. So we need to multiply it by pi, so to get the perimeter, and then times b. This is the width of the rim, and then times t, or this is the depth of the rim, and then times the density. Okay, so inserting it in our formula for computing the moment of inertia, so we arrive in this equation. So the volume times the density over 2g, and then times the outer radius squared plus inner radius squared. Okay, so substituting the value to get the mean diameter, so the outside diameter plus the inside diameter over 2, so that is 24 inches, and then since the radius is given, we just multiply it by 2, so we get 16 inches. Then add the internal and outer diameter and divide it by 2, so we get the mean diameter, which is equal to 20 inches. Then we can solve for the mass moment of inertia. So substituting the values, so 20 over 12, we divide it by 12 to convert it to feet, so inches to feet, because the unit of our density is equal to pound per cubic feet. So multiplying the mean diameter by pi by the width of the rim, and multiply it by to the depth of the rim times the density over 2 times the gravitational acceleration, which is 32.2 feet per second square. And then the outer radius squared plus the inner radius squared, so we get 7.339959 feet pound per feet pound second square. So I choose to round it up to 7 significant figures, since the choices is rounded to 7 significant figures. Okay, so next we need to get or convert the angular speed or the angular velocity from revolution per minute or the RPM to radians per seconds. Okay, so to convert it, since there is 2 pi radians per revolution, and then there is 60 seconds per minute, so multiplying this to 1000 revolution per minute, we get 104.7196 radians per second. Again, I'll round it to 7 significant figures because the choices is rounded up to 7 significant figures. So now that we get the mass moment of inertia and the angular velocity, so we can calculate now the kinetic energy, which is the stored energy in the flywheel. So substituting the value of mass moment of inertia and the angular velocity, so squared, it is equal to 40,245.83 feet-pounds. So the answer is letter A. Okay guys, so thank you for listening. I hope you learned something from this video.